This conference will now be recorded.
Okay, so I think I'm missing one or two uh, sh uh, reference, or not reference sheets, scrap sheets of paper. Usually they send them to me by the morning today. So I am anticipating on grading your exams later on today. So remember, I do grade everything by hand. So if it was just like you got the answer right, but it was a format error, don't worry about that. I'll go back and look through all of those. And if I see that maybe you were on the right track on your paper, but you entered something wrong, I can give you some partial credit on that. Okay, so hopefully those will be completed later today. Uh, just a reminder also, we have project number 1 is coming due. If you want me to be looking at that ahead of time, you have to make sure that you can send me your Excel sheet. I'd be happy to look at your Excel sheet. I don't pre-grade the report part of it, but I will look at your formulas and all that. So remember, I'm grading you on the formulas, the formatting, making sure that you've done it correctly. Also, we want to make sure that you have a formula that calculates the final grade, not that you just add up the numbers at the very end, but there's a formula. And so the example that you can see in your book, I honestly don't remember what page it is, but it's the Happy Widget Company problem in section 6 there. And if you look, and there's an Excel sheet that shows it, it shows like the formula I'm looking for. So you're looking at the number times its percent and so on, but use those cell locations there. All right. So, you know, email me if you have any questions about the project, but that's coming up due and you don't want to forget about that. All right. So officially we are now into Unit 2. Unit 2, we're going to be having a little bit more formulas and equations to be using. And because we're going to be having a little more formulas and equations, you're actually going to be able to use a reference sheet. So in your book, there is a yellow reference sheet. It's towards the back of the book there. I'm not sure exactly what page, but it should be a yellow sheet of paper. And I'll show you what it looks like. We're not going to really be using a lot of it today, but we definitely will be using it next week. But for exams 2 and 3, you're actually going to have the ability to be able to use this. I'll send it to the testing center and they will give you a copy of that. Because we know we're going to be eventually getting into some conversion factors, and we know a lot of these are just kind of hard to memorize. So then what we're going to be working with this today is we're going to be talking about how we can describe change, and we're going to be talking about absolute and relative change. So you can see there's a little bit in here, but this is actually going that next step further, talking about linear and exponential equations. So we'll actually get into that in a future section there. Then we're going to be going on to talk about credit cards, and we're going to talk about interest. If you put money into a bank account, what is it, how will you know what would be the total in your bank account after so many years? Then we're going to be looking at um, how do you figure out what your payment is going to be? So if you're buying a house and you're going to have a mortgage, or you want to buy something large like a car or something like that. So I'll show you how Excel will help you utilize some formulas that are pre-built in there, and it'll allow you to see what your payment is. Then we're going to have something called future value. So if you're saving for the future with a 401k or something similar type of a savings plan, it'll kind of predict what your savings will be after so many years. All right, so it's kind of interesting. People really like this unit too because it's really relevant to a lot of the things that we will have in our everyday life. Okay, so when we're going to talk about interpreting change, we're going to be talking about absolute and relative. So absolute is basically the actual numerical difference between the numbers. So let's say I'm comparing gas prices from last week to this week. So I can say gas prices increased 13 cents a gallon. That would be one way of describing an absolute change. But if I said something like gas prices increased, let's say 23%, that would be a way of expressing relative change. And relative change is always based on the previous value there, that old value. So we're going to be going through the definitions today. We're going to be looking at how we can apply this in some everyday situations. Okay, so absolute, like I said, it's just the difference between two numbers. If you get an answer that's positive, that means it's an increase. A negative would mean it's a decrease in value. So how do I get a positive or negative value? It does make a difference how you set up that subtraction there. So if I'm going to be comparing two values, we always want to take the new value minus what we refer to as the reference value or the old. So it's always going to be new minus old. All right, so here's a very simple example. If we were comparing populations in the United States, so it said in 2006, the population was 298 million, and in 2016, it was 323 million. Now, the good thing about these two numbers, they're both the same unit. They're both in the millions. Makes my life so much easier, because then I can just use the abbreviated form of the number. So I can just simply use the numbers, and then I'm going to get the answer. But remember, this answer is in millions. So if I take the new value, that's in 2016, and I subtract that old reference value, I get a difference of 25. But remember, the unit is millions, so there was an increase of the US population of 25 million people. All right, because this became a positive value. Okay, here we go. Weight loss. You know, Juliet, she went from 180 pounds to 162 pounds. Okay, so 162 is her new value, and we're going to subtract her old, her reference value, what she started with. And so you could see that's a negative value. So in other words, she lost 18 pounds from May to December. Okay, so here's another one. We're talking about the median income in the United States between 2015 and 2016. So here's our new value, subtract from the old. So the mean income actually increased, because that's a positive value, by $1,809. So just be careful with these. It does make a difference how you're setting that up. Now, these are a little bit trickier when you're comparing something that doesn't have like a time factor involved in this. Let's take a look at this, because we have to pay attention what we're comparing something to. Okay, so it says compare Miguel to John by finding and interpreting the absolute change. And it actually is saying use John as the reference. Well, because we are comparing Miguel to John, okay, John was the reference value. The new value is Miguel, because we're comparing him to, you know, maybe the height of what somebody else was already, you know, that we already established. So you got to be careful, because sometimes it says when we're comparing new and old, usually new is where we're going to. You know, if they're saying compare 2006 to 2016, well, we went to 2016, so that's the new value. But in this case, we don't have reference words that are kind of giving us a hint. So we have to pay attention to the way it's worded. So these are going to be the trickiest part, is trying to think, what am I comparing? You know, am I comparing one thing to the other? And, you know, what would be that reference value? Okay, so in this case, we can say that Miguel is 5 inches shorter than John if we're comparing it in the opposite direction. And it says now with Miguel as the reference value or the old value. So we're going to take John's height minus Miguel's. And in this case, we get 5 inches taller. So it does make a difference. And they might even ask you to write a short statement on what that number means. So be careful, how you're saying the names or the words, what you're comparing, because sometimes people get it a little bit mixed up. So hint, hint, you'll probably have to calculate an absolute change and then give a simple statement about what that number means. Okay, hint, hint. All right, now relative change is a ratio. And basically, we're going to take the absolute change, which is the new value minus the old, and we're going to reference it, or we're going to calculate that based on the old value. Okay, so it's going to be that absolute change over the old amount. Okay, so in this case, let's look at that population problem again. So we already knew there was a difference of 25 million people, but let's talk about it relatively speaking. So we would know that we're going to take the absolute change. So we're going to take the new value minus the old, going to get that value, and we're going to divide that by the old reference value. We're going to get a decimal equivalent here. And usually this decimal equivalent, we want to go out about 3 decimal places. And the reason why we want to go out 3 decimal places is because we're going to have a percent that we're changing it to. So what happens here is, since I'm dividing and I've got all the same units, the units wind up canceling each other out in this case. And we get just a numerical answer. Now, we're always going to be converting our relative change to a percent, because relative change is also referred to as the percent of change. Okay, so think about it. Relative change is percent of change. So in this case, it's a positive value. So we can say the U.S. population increased 8.4% from 2006 to 2016. Okay, so remember, 2 different ways of describing change: the actual numerical value, which is positive or negative, and then the percent of change, or the relative change. And that could be positive or negative also, which means increase or decrease. Okay, so here's those same exact problems, but now we're looking at it relatively speaking. So once again, Juliet's weight. So we took her absolute change, and we divided it by that reference value, that old value, and we get a negative 0.1. In other words, and there was nothing else after that. In other words, she had lost 10% of her body weight. Okay, so that's what that stands for. For the median income, we did that absolute change divided by the old reference value. Here's our decimal number rounded to 3 decimal places. And we found that the median income increased about 3.2% from 2015 to 2016. Okay, so you can see the different ways we can describe this change. Okay, here's once again John and Miguel and how they compared these values. So take a look at this. Okay, so let's take a look and let's make a few more comparisons here. You might wind up with a problem like this, definitely in the homework, but you might see something like this on the quiz or exam, where instead of just being given numbers, maybe you're going to have to pick numbers off of a table or a chart. Okay, so in this case, we've got a graph that we're going to be picking something off of. So let's take a look at these questions here. So it says, estimate and interpret the absolute change in median home sales prices from 2005 to 2009. Okay, well, we can see physically what's happening here is the prices are decreasing. So if I don't get a value that's a negative value, that meant I flip-flopped my numbers there. So be careful with that. So, we can see this is approximately 116. This is approximately 110. They're both in the thousands, which makes my life easy because they're both the same units. So I can just take the value, subtract, and then just add the unit on at the end. Notice that all the absolute changes had the unit attached to it. Okay, so in this case, we can say that the median home prices decreased $6,000 between this time frame. Now, if we remember what was going on at that time, 2009 is when we had that last recession there. And this is when, we had all kinds of issues. People were losing their jobs. The housing market, just kind of flip-flopped. And right, all these houses weren't worth the same as they were. So we had people who had mortgages for more than their home was actually worth. So, we had all kinds of issues. Now, if I want to take that a step further and calculate the relative change here, so remember, relative change is taking what we already calculated as the absolute change, and we're going to divide that by the reference value here. You can see we have a negative 5.2%. In other words, when we describe it in a sentence, we're going to say it decreased 5.2%. Be careful not to say decreased and also put a negative there, because that's a double negative. And it wouldn't make sense to say that. So you would actually say it decreased a negative. In other words, it increased, So be careful. Once you say the word decrease, that replaces the negative value there. Okay, in this case, if we're still using the same graphic here, can we see if this statement is actually true? So it said at 118,000 last year, the state's median sales price for existing homes was 4% higher than in 2011. Well, when I look at this table, I'm not looking at percentages here. So I'm not looking at was it 4% higher. But what I can do is since they're saying as a percent, I can actually calculate the relative change here and see if that makes sense. Okay, so if I look at this, it says the graphic does not begin at 0 on the y-axis, so it's misleading, okay, which is true. It doesn't start here. Also, we can check the accuracy by checking the relative change. So we would take the absolute change divided by that reference value, and we get about 4.4%, which actually makes sense. So it says was 4% higher. 4.4 is about 4%, and it's a positive value, so higher. So yeah, that would be approximately an accurate statement that the Realtors Association made. Okay, now, each year, what happens is they call this HUD, which is the U.S. Department of Housing and Urban Development. They compile information on what we refer to as the fair market rental rates. So what this does is it establishes rental rates in the area, and this is used for people who are getting assistance on, apartments and living and food and all of that. So fair market rental is definitely an important value here. So if we look at all these communities here, it just so happens actually that every one of these communities is where a Ivy Tech campus is located. It says in 2000, here were the rental rates. And then in 2015, here are the rental rates. Now, it says the real estate industry also uses this as a guideline when setting monthly rental rates in the area. So, somebody can't come in and turn a unit into a rental property and charge way more than what the market is allowing. Okay, that's what they're setting this up. So you have to be fair. It's fair market rental rates here. So let's take a look at if we were going to compute this. So if I wanted to compute between the 2 years, well, remember, what's the newest value is 2015, and I'm going to compare that to the relative or the old value. So if I do the absolute change in this case, Fort Wayne increased $179, Gary increased 167, and you can see, and so on. Now, every one of these absolute changes was a positive value. That means that the relative change is also going to be a positive value. Okay, so notice the different communities and how their rental rates increased over that 15-year span. Okay, so I mean, really, it is an interesting value to look at. Now, Um, if we were to write a sentence, here are some sentences we might be able to write about some of these to describing those changes. So take a look at this, because hint, hint, you will be expected to be able to write a statement about what those values mean. So, just as long as your statement makes sense, you'll get credit for it, because there's many different ways of stating some of this. Okay, now, what if I wanted to compare between communities? Okay, so instead of using years, what if I say that, I lived in Terre Haute and I want to move to Indianapolis? Okay, so think about it. New is where I'm going to. So since that is the new value, so Indianapolis in 2015 was 792. Okay, so we have that 792, and Terre Haute is the old reference value. So if I'm in Indianapolis and I move to Terre Haute, I'm going to save $114 in rental rates. Relatively speaking, if I calculate the relative change, that is, I'm sorry, the absolute change is moving to, new is where I'm going to. Sorry, I said that wrong. So I'm going to have to pay $114 more. Sorry about that. And then my rental rates increased 16.8%. Okay, so be careful. I was actually getting myself confused here. So new is where I'm going to. So if I was in Terre Haute and I moved to Indianapolis, my rental rates go up. Now, what if I were looking in the opposite direction? Okay, and what if I do this? If I say, let's go from Indianapolis to Terre Haute. Sorry, I was thinking going in that direction. Now, take a look at this. Oops. All right, so in this particular case, if I have Indianapolis to Terre Haute, okay, that means my old and my new values are different. Okay, so we're going to have different values here. Okay, so if I get those values, so if I relative change from Terre Haute to Indianapolis, it's still $114 difference between the numbers. But in this case, if I'm going from Indianapolis to Terre Haute in the opposite direction, that means my rent is going to be $114 less. But relatively speaking, since I'm comparing it to the old existing value, my relative change is going to be different. So just because I change the direction back and forth doesn't mean all these values are just going to be a difference of positive or negative because of that denominator here. So if I go now from Indianapolis to Terre Haute, notice the percent change or the relative change is different when I go in the opposite direction. So I'm going to save 14.4%. Okay, because it's based on that old reference value. So be careful with that. Don't just assume those numbers are just going to be a difference of positive or negative. Actually calculate those out. Okay, now what do we do if they give me the information already in the form of a percent. And sometimes that happens. I'm comparing numbers that are percentages. So here's an example. According to the Bureau of Labor and Statistics, it says the unemployment rate in recent history during 2009, remember that was during the recession, it had a high rate, 9.3%. But by 2015, that unemployment rate had dropped to 5.3%. So the information, the data is already given to me in the form of a percent. So what we're going to do to compare these is we're just going to use the numbers as is, but we're going to refer to them as percentage points. Okay, so look at what it says here. Think percentage points. This means we will not be converting these percentages to decimals during the calculation. We're just going to use them as is and call them a percentage point. So here's an example here. Okay, so I highlighted these numbers here. Okay, new is where I'm going to. So the new value is 5.3. The old reference value is 9.3. So my absolute change is -4. So that means the unemployment rate dropped 4 percentage points. And the relative change, so if I take that -4 divided by the old reference value, I get -0.43. In other words, the unemployment rate decreased 43% between those 2 years. In other words, things got better. There were less people unemployed. Okay, so be careful when the data is already in the form of a percent, we just throw away the percent sign and call it a percentage point and use the values as is. But we still list relative change with a percent there. Okay, because relative change means percent of change. Okay, here's a couple other examples. I'll give you just a moment to look at these. Okay, so we can use this idea now of relative change to talk about inflation rates because this is based on that. So inflation is the relative change with the CPI, remember that consumer price index for 1 year, and inflation rates you can either do from month to month or year to year. So basically what you're going to do when you're comparing an inflation rate is we typically compare it to 1 year previously. So a whole year. Okay, so these are CPI values here for these particular years. So if we wanted to look at the inflation rate and what was happening using the inflation rate. Okay, so if I wanted to figure out the inflation rate for 2016, what I have to do is compare it to exactly the time period before. Since we're talking year, a whole year, we're going to compare it to a 1 full year before that. Okay, so my new value is 2016. My reference or my old value is 2015. So remember, new minus old divided by the old. So in this case, I get this decimal equivalent. And look, they even went out a few more decimal points. Just be careful. Pay attention to WebWorks. They'll tell you how many decimal points they want the answer. And in this case, we convert that back to a percent. So the inflation rate was 1.26%. Okay, so in other words, if I were to, in this case here, how would you expect to pay for goods and services if they were worth $1,500 in 2015? Well, if this is the percentage of the inflation rate, okay, I'm going to multiply those goods and services times the percent. All right, now when I multiply that to actually get the value, I do have to convert that percent to a decimal in this case, because it's saying it increased by that. So in this case, I multiplied by the percent times 1,500. What is that value? Whatever it is, which is actually going to be $18.92. We're going to add that to 1,500. And so last year things were worth, or in 2015, they were worth 1,500. But then this year, based on inflation for 2016, they actually increased to $1,518.92. Okay, so this whole page right here, hint, hint, know how to understand this. Okay, so if they were asking you, what is the inflation rate for a particular year? You use the CPI as a comparison to exactly 1 year prior. If they're asking you, okay, now that you know the inflation rate, how are the goods and services going to change values? Notice you take that relative change, which is in form of a percent, convert that to a decimal, and figure out what is that percent. Okay, another way of thinking about this is if it's increasing 1.26%, we can use what we had previously, that amount over the base is equal percent out of 100. Okay, so if I'm increasing 1.2%, I'm going to take 100 plus 1.26%. So that would be 101.26% over 100 is equal to, well, since 1,500 is the base amount, that would be in the denominator, and it's the amount that I'm looking for. So you can actually use that proportion to solve this also. So remember, if something is increasing, you add to 100%. If it's decreasing, you subtract from 100%. Okay, so here would be the inflation rates based on a few of these years here. I'll let you take a look at that. Okay, now what's really nice about this is we can use this idea. Okay, let me see if where's this at? Okay, okay, so the idea of relative to percent here. So when I'm looking at this, we can use the idea to calculate, in this case, it says sticker price. Okay, so it says the sticker price of a new internet router is $24.99. The total price with the tax included was $26.74. Can we use this information to work through the comparison? So we can compare the total price to the sticker price using relative change. So it would be the new value minus the old divided by the old, and we can actually calculate what that percent of change was. So in other words, we can figure out how much tax was added on there. So in this case, I get this value of 0.07. In other words, I was able to calculate based on the sticker price and then the actual price after taxes what the tax rate was. So you can see we can do something like that. It's more of the same. Okay. All right, so we're going to continue talking about percent of change here. Okay, so it said, remember, we were calculating relative change in order to make comparisons. We're going to talk more about the percent change, and one of the values is known, and we're missing another value. So what do we do in that case? So let's take a look at this example here. So it says, what if the fair market rental rate in Gary is 25% more than in Muncie, where it's $635? How do we find the rental rate in Gary? All right, so if we know that Gary is 25% more than Gary, we know that we can set up that idea of the proportion. So in other words, 100% plus 25%, because that's 100% more. All right, so let's see here. Let's look at those words again, what that means. So in this case, when I have words that say less than, so if they say like something is 10% less, that means I would take 100% minus 10%. In other words, I'm left with 90%. If it's 25% decrease, that means I'm left with 75%, and so on. But if something is more than that, okay, if it's 10% more, that means I'm going to pay 100% of what it's worth plus an additional 10%. In other words, 110%. 18% greater than would be 118%. 50% increase, that means I'm going to add 50% to 100%, and so on. So these are key words that lets you know what percent you're left with or that you have. Okay, so remember, if it's decreasing by a percentage, what am I left with is going to be less than 100%. If it's increasing by a percentage, what I'm left with is more than 100%. Okay, so knowing that, let's go back to that fair market rental. So we know that the rates in Gary are 25% more. So whatever it is, I'm going to pay Muncie's rate plus 25% more. In other words, 125%. So when I'm using the proportion method, my percent is going to be 125% over 100. Now, my base value, we're comparing it to Muncie. Okay, and then in my numerator here, this is what I'm looking for. What is the rate of Gary? So remember, the numerator on this side always refers to after we've taken the percentage here. All right, so we know that this number wasn't after we increased it 25%. So we know this is the one I'm looking for. So if we do our cross multiplication to solve our proportion, so remember, multiply the two numbers across from one another and divide with the one opposite the variable here, we wind up with Gary's rental rate. So it's a little over $793. Now I have to think about it. Does that number make sense? Is it more than Muncie's? Yes, it is. So it makes sense. So one add another example. We're not the Bloomington. Okay. I'm back. Okay. Oh, okay. Okay. All right. So last is a less than. So I would take 100% minus 15%, which means I'm left with 85%. So that's the number I'm going to be using in my proportion. All right, so in this case, that's going to be 85 over 100 is equal to, well, remember, I'm trying to figure out Lafayette's percentage. And so on this side, Lafayette refers to the 85%. So that means the reference value or my base is Bloomington's 82,000. Okay, so I get this answer of 69,700. If for some reason I got a number that was bigger than Bloomington's amount, then I know that what I did was just flip-flop these in the wrong order. I got my amount and my base mixed up. So always pay attention. Does that number make sense here? Okay, let me see. I got a question. Okay, so it's saying, yeah. So I see that, yeah, some people are having a hard time with this connection. Yeah, my connection, I apologize, but it's saying it's coming in and out. Must be an issue with what they have, but it's showing that I'm connected right now. So if for some reason you can't hear me, let me know, but it shows that I'm connected again. Okay, so this is a way that you can use to find the differences between these. We can use that idea of the proportion. So now if I'm comparing rental rates in Fort Wayne and it's saying that they are 13.2 less than rental rates in Indianapolis, can we find the rental rates in Indianapolis? Okay, so if it's 13.2 less than, that means I'm going to take 100% minus 13.2, and I'm left with 86.8%. Okay, and it's just a matter of thinking, do I know the base value? Do I know the amount? And so since we're starting with that base value, um, I'm sorry, it's saying this number, which is 13% less. Sorry about that. This is the amount. So the way this one is worded, it says that this already is after they applied that percentage. So this is going to be, this value 687 already is my amount because it already is after they applied that percentage less than. Okay, so that would be my amount, and I'm looking for the base rate before that. Okay, so just watch how these are worded. Is the number that they are giving you already after they've applied that percentage? If so, that's my amount. Is it before they've applied the percentage? Then that's your base. Okay, here's another one talking about population between Chicago and Indianapolis. So when we're using it to describe, we can't just say the number. This means, we can actually say this value here, or they can abbreviate it's about 2.7 million people. Okay, take a look over here. This is always a popular problem we see on homework quizzes and exams. Jerry is currently earning $20 an hour. He gets a 15% increase with his new promotion. How much will he be earning now? Well, a 15% promotion is 100% plus 15%, so 115%. So I can either take 115% of 20, in other words, convert that to a decimal, multiply it by 20, and you'll get the amount, or I can use that idea of proportions. Okay, let's take a look at some of these other values here. Here's another interesting question. Julianne recently joined a carpool. Although she lives 22 miles from work, on her day to do the carpool, she drives 30% further to pick up her colleagues. How far does she drive to work on her day to do the carpool? Okay, so if she's driving 30% more, then it means she's driving 100% of what she normally would plus 30%. So 130% over 100. We're trying to find what that number is, and we already know her base value. Okay, remember the number has to be referring to after you've applied that percentage increase or decrease. And so since 22 miles is her regular amount, we're trying to find when she does the carpool. So it's the amount that I'm looking for here. Okay, and so she would be driving 28.6 miles on her carpool day. Okay, let's take a look at this. Are relative changes additive? So this is kind of interesting here. Does a 20% increase followed by a 20% decrease turn out to zero? Does that net to zero? Okay, so we're going to be looking at this. Does a 15% increase followed by another 15% increase mean a 30% increase? So we're going to work through a couple scenarios here to see if that's what's actually going on. So this is very true scenario here. So it says times are hard. So everyone at the small company you work for has been given a 10% pay cut with the promise of a 10% increase once the profits improve. So let's just work through a scenario and let's just say, let's do a typical worker there and what would they be making? So we know the typical worker works 40 hours a week. So if they work 52 weeks in a year, that's 2,080 hours total. Now, what if you made $15 an hour? What would your salary be for the year? Well, if I work this many hours, $15 an hour, I'm just going to multiply that. So this person would be making $31,200 for the year. Now, remember, you're going to get a 10% pay cut. So if I'm going to get a 10% pay cut, that means it's 100% minus 10%. That means I'm left with 90% of what I would be getting. So 90% in the form of a decimal is 0.9. So we're going to multiply that times 15. And it's going to tell me what my new hourly rate is. So I went from $15 an hour and I got cut 10%. So now I'm at $13.50 an hour. Now, things got better in the job. Whoa. Things got better and it said now they're going to get that 10% increase back. Now let's take a look. Turned 10% in the form of a decimal is 1.1. So if I multiply that by what I'm currently making at 30, I go to $14.85. All right. Can anyone hear me now? Yes, okay, good, because I'm coming in and out. I apologize for that. Something's happening here with the internet connection. Okay, so what happened is it's all based on what that starting value is. That's what what they're basically saying. So I don't go back to my original amount. So I'm making slightly less money an hour now. Okay, so unfortunately, it is not additive. So If they say they're going to give you a 10% decrease, but later on they'll give you a 10% increase, it doesn't net back to zero. You're going to be making slightly less because that 10% increase is based on a different value. Now let's take a look if I'm going to have differences in adding percentages. So what if you were promised a raise of 40% with this new promotion, and you've got the option of getting the raise all at once, or you can divide that in installments over the next 4 quarters at 10% per quarter? What option would you choose? And a lot of times, this is what they do when they have union negotiations. So a lot of people see that as a 40% increase, but is it really a 40% increase? Is it better? Is it not as good? So let's take a look. So in the first case, you can see what we're working through here. So we just kind of came up with a fictitious amount of value of what somebody would be making. Okay, and if they give you that 40% right away, this is what my raise would entail for that quarter. And so if I do the 4 quarters and add up that same amount, I'm going to be at 70,000 instead of my original 50,000. But if I do 10% per quarter, remember that's 10% of what I'm making the previous time frame, and I'm actually going to come out a little behind. So, kind of be wary. This is a lot of what they do with those contract negotiations. They say, okay, we're going to give you increases, but we're going to do it per quarter. So it really does come out to be a little bit less than giving you that lump sum all at once. Okay, so no, it's not the same. Okay, so here's a question about reasoning with questions here. Okay, how do we understand what these percentages mean here? Here's another one dealing with percentages here, another way of describing it. And I'll go through the last couple because you might see these in your homework assignments. And then here's our last one here. Okay, so this is the gist of section 7. Okay, so I apologize. It looks like we're in and out of internet connection here with a lot of us here. But if you have any other questions, I'll try to stick around. Hopefully my audio will stay on. But this is all I have for our session today. This is section 7. Just a reminder, I will be grading those exams later on today. And I'll be comparing it with your your scrap sheet. And don't forget, you should be working on that project 1, that gradebook project, because that's coming up due. And if you want me to look at your Excel sheet ahead of time, just email it to me. Don't submit it, email it to me. Okay? And I'd be happy to look at your Excel sheet. All right, so that is all I have for you today. You are free to go, but I'll stick around if you have any other questions. Oh, yes. I go through every single question by hand. So, yes, a lot of times the computer won't grade some of those. So, your grade, whatever is posted, is not the final grade because, right, the computer doesn't grade the worded ones. Okay, any other questions out there? Okay, so I am going to be logging off.